So this is my physics project. I created a mousetrap car. My original idea was to use the elastic energy from the mousetrap in this metal piece and attach that to a string right here and attach the string to the wheels in the back. And as it turns the other way, the wheels would move. However, that didn't really work out. So I decided to hammer down a nail right here and use an actual rubber band for elastic energy. And so what I'm going to do is, what I did was I added wheels in the bottom, trying to reduce friction as much as possible. And this is a spring balance, and I'm going to use it to measure the mass of this car. So I'll just attach it in the bottom right here. And it reads about 0.52 newtons, or 52 grams. So I have a slope right here. So my car is going to go up the ramp. I measured the height, and it's around 12 centimeters, so that's 0.12 meters. And what I'm going to do is use this right here and attach that to the car, and I'm going to pull back, and that would just release, and then I would release the car, and that would convert my elastic energy into kinetic energy. And finally, as it goes up the ramp and it stops right here, that would be my gravitational potential energy when my velocity is 0. Okay, so I'm going to try to prove that energy is conserved as the cart moves up the ramp. So say this is my ramp right here. I would call this stage 1 and this stage 2. This is right before the rubber band was released and the car was moving up the ramp, and this is where it stops. We know that the height of the ramp is 0.12 meters, and we also know that the mass of the cart is around 0.52 kilograms. So we can use these two and gravity, which is 9.8, to find gravitational energy, and that after I calculated that, we would get 0.0588 joules. Since velocity is 0, that means kinetic energy is 0 at 0.2, and that also elastic energy is 0 because the rubber band was already released. Therefore, the total energy at 0.2 would be equal to the gravitational energy, which is 0.0588 joules. That means that the energy we start out with at 0.1 is also 0.0588, and that way we can find out the elastic energy that was used in the beginning. The kinetic energy once the elastic is released at this point would be equal to the gravitational energy, which is E total, 0.0588. And in order to find the velocity, I would use this equation, and when I find V, that would give me 1.5 meters per second, and therefore I can find the velocity of the car when it starts out, when it just starts moving. Now I can see that energy is conserved throughout the ramp because the total energy does not change, even though gravitational energy elastic energy and kinetic energy could change, but the total energy does not change. If I had a way of calculating the actual elastic energy at point 1, it would be a little more than the total energy that we have, and that is because some of the energy is lost to sound or friction or air resistance. So the one we ended up with is actually not the actual elastic energy. That's because of all these factors that can affect and can cause energy loss. And that's how we can prove that energy is conserved when a car is moving up a ramp.